Hello everyone. In this video we are going to briefly talk about SolidWorks ScanTo3D add-in. So as you know, SolidWorks is not really meant to work on mesh files and convert them into a surface or a solid model for reverse engineering purposes or other similar applications like what you do with CATIA, Digitized Shape Editor, or other environments. But now they added what we call an add-in called ScanTo3D, which gave SolidWorks the capability to handle some small size mesh files. And by small size, I mean as long as the number of mesh points or triangles stay below 40, 50,000, this add-in can work on them. But once you pass those number of points, this is not going to do an amazing job and sometimes fail, or it takes it a lot of time to do something. Okay, so it's not like CATIA Digitized Mesh Editor that can handle mesh files with millions of points. So still, if the part, as I said, is a small or moderate number of points, it can do some conversion of mesh into surfaces, recognize surfaces, create solid objects in some scenarios, and help you recover a solid model out of a mesh file. So to show you the demo, first thing I need to mention is this is not by default active. You have to go to Tools, go to Add-ins, then make sure this guy here says ScanTo3D, this is checked. So I have already done it. So now I'm good. And now, if you have an STL file, you can go ahead and read it into MATLAB using this ScanTo3D. So when you go to open, right, instead of just opening a regular STL file as you did in the past, and most of the time says, hey, I can only import them as a surface or something. Now, you can go under all files and then read it as a ScanTo3D mesh file. Okay, and when you get that in, you will get this mesh here. And now you can convert it into a surface or into a solid object, depending on the size of the mesh and the complexity of that. So, as I said, this is not really exported from a scanner. It is really exported from a SolidWorks model, this guy. And the goal is, if I have this ball here with this small flat surface on the top that you can see, and I have exported it into a mesh file that you can see here, can I now go ahead and convert this mesh file, pretending that it is coming, let's say, from a scanner? Can I convert it back into a solid model? Or if I got this from some other website or somebody else's shared STL, can I make a solid model out of that? And the answer is, again, depending on the size, yes. So if you go here and right click on this mesh, then you can go to Mesh Prep Wizard. And in the Mesh Prep Wizard, you go forward, and then it says, okay, do you want to reorient the mesh? So if you do not like this orientation of the mesh, you can go ahead and let it automatically, or using references or using numeric inputs, basically change the location of the mesh or the orientation of the mesh, right? So let's say I need to rotate this 90 degrees or so, correct? Then I can go ahead and rotate, right? About x-axis, about y-axis, right? So all I can do is say, hey, rotate this 90 degrees about the x-axis, and then I can ask it to move it up or down for me, right? So you see here, I can bring it in any direction that I want. So I can control its position and orientation if the one that you inserted is not appropriate. Then I go to the next stage, and here if there is erroneous data, you can trap it using a box, using a lasso or anything, a brush, and get rid of that. So many times when you bring data from a scanner, there is erroneous data on non-manifold edges, vertices. There are some isolated vertices, triangles and so on. And if there is any of that here, you can do a cleaning. Okay, now of course we don't want to do anything on this. This is a clean file coming, but definitely, as I said, if you, let's say, go to brush and then brush some areas like this, it is definitely going to get rid of that area for you, right? So now if you say delete, okay, let me show you. If you look here, definitely that area of the exterior of that is eliminated. So what you see here is the inside of it, and let me get rid of the edges so you might see it better. So you clearly see that I have eliminated that area. As I said, not a good idea in this case because this is a clean mesh file. So you go forward and don't select anything in this step, then go and you can do global simplification. So here it tries to decimate the mesh and downsample the mesh and tries to reduce the number of triangles and the points. So when the mesh size is smaller, it makes further processing a lot easier. Now here I only have 5,800 triangles, but if I want, I can bump up this simplification ratio amount, and this brings down the number of the vertices 20% below what it currently is, right? So if I apply that, let's say 24, 25%, if I bring it down to that much, you see it brings down 5,800 triangles into 4,300 triangles. And what it does, if you look now, because the locations of the points are downsampled and changed a little bit, many of those triangles that you had are now going to be changed in terms of the shape, and you're going to get some bigger triangles in some places, sometimes maybe smaller, and maybe the surfaces that it can later create out of these meshes or fit to these meshes are not going to be as clean as nice. So my suggestion is, you see here, it is not in that small circle, the flat area. Now it is not doing as good of a job as last time did. So if I go back here, you see this circle, which is the circumference of that flat area, is much cleaner compared to when I, let's say, reduce it to 50% or so. Okay, definitely now you have a deformed surface. Of course, you get a lot smaller mesh, but when the mesh size is small, simplification is going to ruin the quality. It's really good when you have a huge number of mesh points or triangles. So again, in this case, I absolutely do not recommend you do a global simplification. At best, if you want to do something, do a local simplification. So you can trap an area in a lasso or a box or something and basically do a simplification locally. So for example, let's say here, this is the bottom of the sphere, which is just a single point. So here you have tons and tons of triangles. If you look here, and maybe you don't need those many triangles here, right? Let me see if I can zoom any further. It is going a little bit slow, as I said, although my laptop is relatively fast, but when it comes to mesh handling in SolidWorks, do not expect unbelievable results to come in. It's not going to happen, because SolidWorks is not really made for handling huge mesh files. So now, can I, in this local area, do a little bit simplification? And the answer might be yes. So here, again, I grab my pen, right? And let's see, I grabbed a little bit more than what I should. You go back again and just to this inner area. It allows me to, there we go. And then let's make sure I have grabbed everything. There we go. Right, so now this is the reduction amount, but that is the local reduction. So let's say here, bring it down to like 40–50% or so. So now if you go forward, you see it reduced it, but it's not like a huge effect. So a local smoothness might be good. The other thing is, decimation. The other thing is smoothness. So here it tries to shuffle around, not really kill the number of elements, but shuffle around and then try to see if it can make the overall surface smooth. If the surface you brought is amazing and nice, beautiful like this, of course this is not really coming from a scanner, so it is really smooth and nice. Otherwise, it's always a good idea to apply some smoothness, right? And then let SolidWorks to smoothen it a little bit, because later when it wants to fit a surface to it, it makes life a lot easier. And then once that's the case, the mesh prep is ready, then you allow it to launch the surface wizard, where it can create surfaces that match patches of the mesh. Okay, so it is going to create a bunch of surface patches, which together will model your entire object surface. You can guide it, or you can let it automatically recognize the surfaces. So here I go with automatic recognition. And then, excuse me, here you can tell it how many details you want. Do you want it to grab smallest details? Then it needs to use a lot more surface patches. If you don't care about too much of small details, you basically bring it down, and then it is going to use a lot less number of patches. So here, let's say I want to grab a lot of details, and then that makes the job of it a little bit more computationally demanding, because it tries to capture as much as it can and has to use a lot more surface patches, but still should be able to do that. And yeah, it's almost done. There we go. And then say, hey, look, this is what I could recover for you. And if you look at it, this is the object that it could recover for me. Now, is that really perfect? Not completely, but if I say OK, now you see it converted it into a solid object. And if I show shading without edges, then you see it got the ball. It got that flat area here too if you zoom. Not as perfect as I expected, but if you look into this area here, there is some flatness going on. Okay, it's not like perfect. If you look at it from a side view, I assume here, you can see that this is like a flat area, right? Let me get rid of them. So you clearly see that this portion is that flat area. And now if I apply some color to it, something similar to the original part, or apply some material to it instead, right? Because that ball I just showed you, this one, that this model is coming from, this one is made of copper. So what I can do is also apply copper to this guy and put them side by side for you to better see. So here we go. And now you can see that I could reverse that solid model that was exported to STL, I could reverse it back to another solid model. So now these are both solid models. But this is a solid model basically, which is contained within those surface patches. Okay, there is no parameter or anything like a sketch, a revolve angle. So this is a parametric model that we had. And this is what? This is what we call an imported geometry, or it's kind of like what we call a DOM solid. Although the geometry of them both look the same, right? So for example, if I go ahead and export this one as STL, and so call it maybe ball 1 and save it as STL. This is the one that I imported. So ball 1 and ball are now both what? STLs of the same part. And now here I have imported both of them into Prusa Slicer and put them side by side. You see they look very similar. Of course, this clean cut circle that I had, I don't have here. And the surface of this is smoothened and a little bit different than the surface that I have for the parametric model. But actually, if you look here, this looks a little bit smoother than this one is because of that application of a smoothnet. If I didn't do a smoothnet, probably I would get something very similar. So here is that same mesh to surface creation, but this time I used no simplification, no smoothness, and I used the maximum details I could. So now I got this circular cut on the top a lot better, and now I save this as another STL called ball 2, and I have added it to Prusa. So now if you look, this is the original one. This is ball 1 that I brought with simplification, where the details were a little bit kind of eliminated, and now this is ball 2. And if I bring them closer, and you can see that ball 2 is a lot closer to original one than ball 1. You see this kind of crater shape is not as smeared as it was in ball number 1, because I avoid simplifications, smoothness, and I use the maximum details I could. So this is the idea of ScanTo3D, and again, I have to warn that if your surface of the STL file has sharp edges, then when you convert it into surface and or solid model, you're not going to get as clean and sharp abrupt transition. So let me show you one example here. Let's say something like this. I bring in, you see, here I did not bring it as STL file of ScanTo3D. I just opened it. When you open it, you see it doesn't bring a mesh in. It directly brings it as imported object. Okay, and does not allow you to do anything to it. So if you really want to do that, as I said, if you want to be able to do any modification to the STL file, instead of just directly open it, you have to go and change this all files to ScanTo3D mesh files, then bring it in. So you definitely import it as STL file, not as a solid model right off the bat. So here we go to Mesh Prep Wizard, and we can reposition it or reorient it. Here I am not going to do that. I'm good, no erroneous data. I can do any simplification. Let's not just do it. Let's apply no smoothness and then launch the Surface Wizard, do automatic feature recognition, use as much details as possible, and let it do its job. So what I want to tell you is, in this area at the bottom of the cone where you have the sharp edge, when you want to model it with the surface, you are not going to get as crisp, sharp edge as the STL shows. And there might be some surfaces with errors that it detects, and it allows you to either use a sketcher to tell it, basically using a sketch, basically allowing it to create the surface by guiding it by the sketches you want, or you say, no, I don't want to delete anything, and let it just try its best without you giving it any guide. So as I told you, there is automatic surface recognition or guided one. And here I'm just trying to let SolidWorks handle it the best that it can. Okay, and once it's finished, it's gonna let you that it is complete, and you can OK that. So you see it is having a lot harder time because of the sharp vertex and the sharp edges I have, and it could not do as simple and as nice a job compared to the very simple smooth sphere that I had last time. And one of the reasons are these X's that I have too, those small cuts, but it seems like it could do it. And now if you look, it could actually do a relatively good job, I would say. The only things you have are these distortions here, right? You see, definitely it could not do those small sharp edges. This here, you see a little bit more fillet than the actual model, but still not too bad. But here are the main distortions under these X areas. And if I show you without edges, the distortion can be seen a lot better. And these are those areas that the error happened and it could not really make it a perfect cone, right? But relatively, it could get a quite decent job of reconstructing that mesh file into now this solid model that you can easily 3D print or do any modification on it. So that's the difference. If I had the mesh file, I could not just do a cut extrude through a mesh file. But now that I have this solid model, so here I go to this bottom plane, which I guess for this one should be the right plane. I go to the right plane, go to sketch, and then I would draw a circle, right? And if I want, I can basically get that circle to the original circle of the shaft here. I can use the perimeter circle, and I can click on 3 points on the mesh points, on the surface points. So this is that original circle, and I can use it for construction. And then I do another circle, which is concentric with this one at the center, right? And now that I have this circle, I can easily do a cut extrude through that solid model that I just fit to the mesh file. So here I will do a cut extrude through it, and you will see that I can make it happen. So that's the advantage. There we go. That's the advantage of having a solid model versus a mesh file, because first of all, the mesh file that is hollow inside, you cannot 3D print. It has to be solid and save it as STL before you can 3D print it. If you want to manipulate the file, you cannot do a cut, a clear, nice cut like this through that mesh file, because it's just a bunch of triangles, and when you try to make a hole through it, the edges of that hole are gonna be basically a bunch of dents that are the portions of the triangle edges. So when you convert it into a solid model like this, then you can do all sorts of manipulation to it. So hopefully this brief video on ScanTo3D in SolidWorks, which is one of the SolidWorks add-ins, is useful to you, and I will see you in my next video. Thanks.